So with our theoretical probability, playing cards or just a deck of cards is something that we see throughout really any type of probability chapter. So let's take a look a little bit more about what a deck of cards looks like, certain things that are in a deck of cards, and so forth. So it says a standard deck of 52 playing cards consists of 4 suits: clubs, spades, hearts, and diamonds. Spades and clubs are black, while hearts and diamonds are red. Each suit contains 13 cards, each of a different rank. An ace, which in many games functions as both a high or a low card, cards numbered 2 through 10, a jack, a queen, and a king. The jack, queen, and king are called face cards, right? So if I think of my face cards, it's these last 12 here. Those are my face cards, literally the ones that have faces on them. So I'm not going to ask you too hard of questions. We'll go through and just sort of look at how we can find these theoretical probabilities. So example 3 says, compute the probability of randomly drawing an ace from a deck. So if I think of an ace, that's this here, these 4 here. And so the probability of an ace, my denominator is always going to start with 52, and I have 4. So if they want it as a reduced fraction, we could do 4 divided by 52. Right, find it as a decimal. I could hit math, enter, enter. So 1/13 would be the probability if it wanted it as a fraction. If it wanted it as a decimal, 0.077. Or if it wanted it as a percentage, right, 7.7%. So the homework you'll see sort of asks a variety of things. So it'll ask for reduced fraction, decimal, or even percent notation. So let's look at B. B says compute the probability of randomly drawing a red card from a deck. So red cards, there's, right, half are red, half are black. So that means there's 26 red cards, 26 black cards. So the probability of drawing a red card would be 26 over 52. Which is, you could say 1/2 or 0.5, right? There's a half, right? 1/2 chance, right? 50-50 chance of choosing a red or a black card in a standard deck of cards. C says, compute the probability of randomly drawing a face card from a deck. So probability of a face card. So these are going to be the jacks, queens, and kings. There's 3 in each suit, 4 suits. So there's 12 face cards out of the 52. So if I want it as a reduced fraction, I'll type that into my calculator, hit my math button, and enter twice. So I get 3/13. Or if it wanted it right as a decimal, it looks like it's roughly 0.23. So these are just some basic probability questions on our deck of cards. So let's take a look at our next example. So example 4 says, let's say you have a bag of 20 marbles, 14 yellow and 6 blue. If you pick a marble at random, what is the probability that it will be yellow? So write 20 marbles, and then it tells us the breakup of them. So we want to know the probability of a yellow marble. So I have my denominator, which is the total number of marbles. So this would be 20. And then let's see, 16 yellow and 6 blue. So we'd have 14 yellow. So again, you could reduce it, or you could just say, right, 0.7 would be my probability of choosing a yellow marble from this bag of marbles of 20 marbles. So let's take a look at some properties of probability. So there's 6 that we'll talk about. The first one being, right, the probability event is expressed as P of whatever it is. So you'll see with that throughout this section, I've been writing that, right? The probability and then whatever the event they're talking about. 2 says the probability of an event must be between 0 and 1 inclusive. So what that means is it could be 0. It could also be 1. And anything between. So if it's in, decimal notation, fraction notation, it should be between 0 and 1. Now, if it is percentage, right, it wouldn't truly be between 0 and 1 inclusive, but if you took it out of percent notation into decimal notation, it should still fit between the 0 and the 1. The third one says, if the probability of the event is equal to 0, the event is impossible, right? So that could be something like, find the probability of drawing a green card from a standard deck of cards, right? That would be impossible. No matter how many cards you choose, you're never going to choose a green card because we only have red and black cards. Now, the sort of converse, the fourth says, if probability event is equal to 1, the event is certain. So maybe that's something like, find the probability of drawing a red or a black card from a standard deck of cards. And in that case, since black and red cards are my only option, I'm guaranteed to choose a black or a red card every time. So that event would be certain. And our last two ones. So the fifth one says the probability that A does not occur. We talked a little bit about this previously. It's a complement. And it says the probability of not A is equal to 1 minus the probability of A. So if I know the probability of A, I can subtract it from 1 to find not A. The event that A does not occur is called the complement of A. Our book uses, so they use A and then a little c for the complement. Other books sometimes use this notation here. So they say A prime or A complement. It doesn't really matter, but just understanding what that notation means. And our last property says the sum of all the probability outcomes will sum to 1. So if you have all of the possible outcomes over the denominator, sum it up, it should always be 1. So it says if two events are complementary events, then to find the probability of one, just subtract the probability of the other from 1. The notation used for the complement of A is not A or A complement. All right, so our example using this idea of the complement says, example 5 says, suppose you know the probability of it raining today is 0.12. What is the probability of it not raining? So we know the probability of rain, right, is 0.12. So we want to know the probability of not rain. So this would be something we could say, okay, well, the probability of not rain is equal to 1 minus the probability of rain. So 1 minus 0.12. So 1 minus 0.12 would equal 0.88. So that would be the probability of it not raining.